Alright, welcome to the terminal challenge for Redis bug hunt. I haven't been recording a lot of videos lately due to the holidays, but here we are back at it. And this one involves a little bit of remote command execution and using some weaknesses in the way that a web service is set up to leverage Redis to basically get some sort of command injection and execution on a system. So let's hop over. The only hint we get for this challenge is this blog post talks about pen testing Redis. Some interesting tips here. If we go to the actual challenge, though, we'll see the following text. We need your help. The server stopped running. All that's left is the maintenance port, and it says we can curl this to see what's going on. And the goal of this challenge is to get the source code for the index page. We can see that this is using PHP, and PHP, is generally the server-side language, and that source code or that code runs on the server and decides what to render to the user. So typically, most of the time, the user will never see or be aware of the PHP source code, and if they are, that can actually sometimes be a problem. So we need to figure out how we can get access to that source code as a regular user. Now, they said we have this access to this maintenance port or maintenance page, and it's giving us a couple examples here when we try to curl it, so we can just run those and see what happens. Okay, so if we run help, it says running Redis CLI. So it looks like we are running the command line Redis tool, and it is just blindly accepting our input and executing it under this command. If we try the other example, mget comma example one, comma to separate commands, we get the output. The site is in maintenance mode. So mget is grabbing a variable, the value of a key inside of the Redis application, and displaying it for us. So we see basically we have some level of arbitrary command injection here with the Redis CLI tool, and my guess is we're going to want to figure out how we can exploit that to get the source of index.php. Before getting too far into this, we see that we're curling localhost, and if you're not aware, localhost means the current system that we're on. So we can just try going, actually first let's see what's running on the system. Let's try to figure out what process or server is actually executing this PHP. So if we do ps space AUX, that'll list all the processes running, and we can see here Apache 2, which is a very prolific, commonly used web server, is running. Looks like the user www-data is delegated the work of running Apache. And we've also got Redis running as root. So I know just from experience that the configuration files for Apache servers are typically located at /etc Apache 2. If we do an ls on that, the sites enabled folder is where there are usually symbolic links to configurations for the sites that are actually running on the Apache server. And we can see that there's a link to sites available. So if we just cat out this configuration, we can figure out where the root of our web server is. So the PHP source code should be somewhere in var www.html. So if we just try to go to that, well, we get permission denied. And we can see that based on these permissions, only the owner of this directory can access the contents in this folder, which is www-data. As we can see clearly, we're not that user, so we can't get access to that. So there's no way going around this Redis RCE. So we're just going to have to figure that out with Redis. So if we go back here, after taking a look through this page, you come to this kind of example here on how to essentially create a file on the server and inject content into there. And here they're creating a PHP file with some PHP code that calls the PHP info function, and that function just outputs debug information regarding the server that it's running on. That's sometimes useful to attackers. Another better thing to put here would potentially be if you were looking to exploit this, like a fully or semi-interactive web shell. For our purposes, we want to keep in mind that the only goal we have is just to get the source of index.php. So we don't need any fancy, reverse shells or fully interactive command injection. We just need to get the source of index.php. However, we can still use this example and just tweak this PHP. And if we can curl that, then after we create the file in the right spot and can access it, then we'll be able to use some of the functions in PHP to hopefully display the contents of index.php. So first thing they do here is they are setting the directory, some sort of configuration directory here, to the path of the website folder, which we actually know now as var www.html. Due to our hunting of looking around with Apache, we know that now. And now they set a DB database file name, and they name it as redis.php. And then they set a key value pair, and inside of this database, which is located inside the web directory, and they save it. And so what this is doing here is it is essentially just creating a file called redis.php in the web directory and injecting this content in there. So this is exactly what we want to do. We're going to have to craft up some basic PHP code that's going to cat out our index.php file, and then we should be set to solve the challenge. So first thing we want to do, config set dir. Actually, we can't just type it in, obviously, so we need to go through the curl route here, command, okay, so config, and then we use commas, not spaces, to separate our commands, so config, comma, set, comma, dir, comma, /var, www.html. Okay, we can see that it executed our command, just as expected. The next step we want to do is set the database file name. So we'll just name it set db file name to hacks.php. Config set. Oops. Config, comma set, comma db file name, comma hacks.php. Okay, we get an okay. Next, we want to set the content. So we want to create a key value pair. This probably doesn't matter what it is, and then the value is going to be our PHP. So since I've already solved this challenge, I'll save some troubleshooting here. But since we're sending this through, we're going to have to create or craft some PHP that has spacing in it, and that can get a little tricky sometimes when you're sending it, as a URL parameter. So we're going to have to do a little bit of URL HTML encoding to make sure this gets passed over HTTP properly, and the server interprets it as it should, or as we intend it to. So here is some PHP that I wrote. Let me just open good old Notepad here. So this PHP is very simple. We assign a variable output to receive the output from this shell_exec PHP function that simply takes as a argument the command that you want to execute at the shell level, as if we were in a terminal. And for that, we want to do cat index.php so that we extract or cat out the contents of the PHP file, essentially the source code. and we want to make sure we redirect all output into standard output. We save the output of this, which is going to be our source code, into the output variable, and then we echo that out, and echo just basically prints out the output. So when we, as a user, request this page, we should get the output of a of index.php's actual source code. So, like I said, the next problem is we've got some interesting characters here, spacing and different characters that are typically used in URL parameters. So if we were to try to just paste this in there and send it, or you would get some sort of an error. The easiest way to avoid that is to simply encode it. You can do this with all sorts of different programs and tools. Burp Suite will do this. Apparently on Bing, you can just Google URL encode, and you'll get an encoder. Don't hate me too much for using Bing. I'm using Edge to record these videos just because it's easy. I don't have to tweak the browser when I start and stop. I don't normally use Edge. Anyway, so let's go ahead and take this PHP code and paste it in there and hit decode, or excuse me, encode. We want to encode it. And now we get this output where it has changed. We can see the two side by side. We get these percent signs and these encoded values now. So like a question mark turns into %3f now. Okay, so this is encoding it, and we get some pluses here for spaces. So that when we send this through HTTP request, it gets received properly, decoded properly, and there's no issues with funky characters like spacing or apostrophes or question marks. All right, so let's take all this content, and now we want to do the step where we set a key value pair. So we'll do set, we just do test just like they did, and we'll paste our, oops, I keep forgetting we have to do this via web request. So set, comma test, comma our PHP, and we'll hit enter. Okay, so we're getting, it's having an issue with that encoding, so we might have to use a different encoder. Okay, so this looks like it's actually encoding the parentheses, so let's try this one instead. Thanks, Bing. Yeah, and like I said, if you want a tool, you can download Burp Suite Community, and it's got, I know, all sorts of different ways you can encode. Okay, so our validation that this worked is we can see that that string was decoded, and we get our expected value here. So the next thing, we've got basically this file created, this database file with this key value pair in it. Next thing we can do is try to curl. Oh, last thing we need to do, and this stumped me the first time I went through, is actually save it. So we'll do the save command here. Okay, and the last thing we have to do is curl that file that we created, and hopefully this works. Binary output can mess up your terminal. Okay, so we don't care. Give us the binary output. All right, there we go. So as you can see, we found the bug, so it clearly printed out the source code here, and that appears to have solved the challenge as indicated by the pop-up here. And now we get some hints for other challenges. If you have any questions, let me know in the comments. Be happy to answer, and we'll see you in the next one.